Today we're going to talk about the basics of quadratic functions and what their graphs look like. A quadratic function is a function with the degree of 2. So if you remember in our polynomial unit, we talked about having different degrees based on their exponents. We have done a lot of linear functions this year with just a degree of 1, and quadratic is what we're going to get into with a degree of 2. So since it has a degree of 2, that means the highest exponent is 2. The standard form equation is y equals ax squared plus bx plus c. This should look familiar to you because we have already learned how to factor these trinomials. So it's quadratic, usually a trinomial. It always has a degree of 2. Quadratics form a shape that's called a parabola. And it is kind of like a U shape, like this graph down here. It can also be flipped upside down, like this. That is a parabola. Okay, next let's look at the graph. So we have this nice parabola shape. There's a bunch of different pieces we need to talk about. The first piece we're going to talk about is down here. This point is the vertex. The vertex of a parabola is the maximum or minimum value. So it's either at the very top, it would be a maximum when the parabola is opening down, and it's a minimum on this one because the parabola is going up. It's the turning point. So again, sometimes it'll be a maximum, sometimes it'll be minimum. It depends on which way our parabola is facing. Next, we're going to look at this dotted line. This dotted line that goes right here in the middle is called the axis of symmetry. Symmetry means it's the same on both sides. So this axis of symmetry, this line, if I take this part of my parabola and I flip it over this line, it's the same. So it's the same on both sides. It kind of is a reflection over this line, this axis of symmetry. And that always goes through the vertex. It is halfway in between these 2 points, which I'm going to get to next. These 2 points are the x-intercepts . There's some other words that we need to know that go with x-intercept. With quadratics, a lot of times with quadratics, we are going to be asked for the solution. The solution is the x-intercepts. They are also called roots and zeros. Sometimes there are 2 of them, sometimes there are 1, and sometimes there are none. The last piece of our parabola here, this point, is our y-intercept. These are the basic parts of a quadratic or a parabola. We have our x-intercepts, our solutions, zeros, roots, whichever word you want to use, they all mean the same thing. The axis of symmetry, that line in the middle. The vertex is that maximum or minimum turning point, and then the y-intercept is where it touches the y-axis, and that changes depending on the graph. So these 3 graphs, we need to write down the number of real solutions. So on this one, we had 2. We can have a maximum of 2 because of our degree of 2. This one does not touch the x-axis at all, so there are no real solutions. Well, we can either say there's no real solutions or we can say that they are imaginary. Most of the time we will say they are imaginary. Then sometimes we have a parabola that looks like this, where there's only one x-intercept. So we can just say this one has one solution. Only has one x-intercept. And graph C is kind of like the one we have over here. There's two x-intercepts, so there are two solutions. So you'll see as we get into quadratics that many of our quadratics will have two solutions. Some of them will only have one solution, and some of them will have imaginary. So let's practice identifying the parts of a couple graphs. When I look at this one, first question is there a maximum or a minimum? So I look up here. Since our parabola is facing down, this is my maximum point. My vertex is my maximum point, which is at 3, 4. Axis of symmetry always starts with x equals. So if I go back and look at my axis of symmetry goes right through my vertex, it is the x equals line. If we think back to our linear functions, x equals is a vertical line. So we just want x equals, and this is at x equals 3. We can always steal that from the vertex. This will always match up because it goes through the vertex. Our y-intercept is at 0, -5. And our x-intercepts, or the zeros, are at 1 and 5. We can write that as points, 1, 0, and 5, 0. Or we could say x equals 1, x equals 5. One more example. So this one, we see that our parabola is opening up. So this is a minimum value at the vertex. When we look at our vertex, we have -4, and we see this is going by 2's. So this would be -4, -9. Our axis of symmetry goes right through the vertex in the middle. Always x equals -4. Again, can steal that from my vertex. Y-intercept, here's my y-axis. It looks like it intercepts right here at 8. So we would say 0, 8. Whenever we're finding the y-intercept, we should have a y number and x is 0. For the x-intercepts, they are at -7 and -1. -7, 0, -1, 0. Or x equals -7, x equals -1.